get to the issue. And what is the issue? It's what type of planet do we want to live on? What temperature do we want the planet to be? What atmosphere do we want it to be in terms of the concentration of CO2? You know, how do we want to live in the future, and how do we get to that future we want to live in from where we are today? The first thing you need to do to be able to do that is say, well, what temperature do we want? All right, what tools do we have to answer that question? What temperature do we want? You've probably heard about climate models. This is what scientists use. These are models that include physics and chemistry and the flow of the atmosphere and the incoming solar radiation to figure out what temperature the planet will sort of average out at if, you know, some climate change happens. And then we have scenarios. Scenarios are the things like business as usual. If humanity continues to burn fossil fuels as it does, that's one of the scenarios. Another scenario might be what happens if humanity chooses to do massive investment in non-carbon or low-carbon energy generating technologies. We also have another tool in the toolbox that's called impact studies. Impact studies are the things that make the headlines. This is like at 1 degree Celsius, we're going to lose this species here. At 2 degrees Celsius, the coral reefs will die. At 2 degrees Celsius, the Himalayas will melt and we're going to not have fresh water for Asia. At 3 degrees Celsius, sea levels will rise a certain distance and we're going to lose countries. Impact studies are the least accurate, but they start to give us a sense of the future that we might live in if things play out that way. All right, so let's look at those climate models. Climate models are getting very, very good and they're getting more accurate, but we really express them in terms of something like uncertainty. So we know that if, for example, we hit 450 parts per million of CO2, that's the concentration of carbon dioxide molecules in the atmosphere. If we hit that 450 ppm, we've got about a 30% chance of staying below 2 degrees and, you know, a 60% chance of going above that. And that's the uncertainty. But we definitely know that it will take us a long way above the temperature we were in 1990. The scenarios give us an idea of what will happen. On the business as usual scenario you see here, that's the most aggressive of these, we'll have 5 or 6 degrees Celsius, that's more than 12 degrees Fahrenheit, increase in global average temperature by the end of the century. In the best scenario that the International Panel for Climate Change has had in the scenarios to date, we get more than 2 degrees Celsius temperature increase. That should worry you a little. We want to do probably even better than that best scenario we've got so far. Impact studies. This might be how you choose the temperature that you're prepared to tolerate. You know, again, there's a litany of horrors that we are warned against if we go past these temperatures. And you probably want to pick, you know, how far up that chain do we want to actually go? And so the sort of general consensus today is 2 degrees Celsius above 1990 levels is as high as you want to go. Because not only do you get these environmental problems and food scarcity and droughts and etc., but you also get into the risk of irreversible feedbacks. Things like the tundra emitting methane as it melts, things like Greenland melting very quickly and increasing the sea levels very quickly, as well as increasing the ocean's capacity to absorb sunlight. So let's say we've chosen 2 degrees as the highest temperature we want to go to, and we're prepared to accept 450 parts per million of CO2 in the atmosphere as the upper bound of carbon dioxide we can tolerate. Now we have a target, and we need the planet to commit to that target. If you don't have a goal, we're not going to hit it. The other nice thing about having that target is the engineers can then say, all right, I know what I have to do to get there. In fact, everyone on the planet can have this sort of goal. This is what we have to do. I think once we get the conversation about climate change and energy there, we're in really good shape because we know what we have to do to have the planet we want to live on. So let's talk about 450 for a second. It may not be quite as rosy as we want. Here, for example, is a list of the history of the targets that's sort of been proposed. The EU and the IPCC and the Stern Report of England were sort of saying about 550 or 650 ppm a few years ago. America's best climate scientist, Jim Hansen of NASA, he's really proposing 350 ppm should be where we go. Why does he say that? And I think it's a very logical argument and it's very reasonable and we should be able to understand it. He argues that humanity sort of evolved and our civilizations developed and blossomed in a period where the atmospheric concentration of CO2 never went above 350. So that's pretty logical. The only problem with that is we're already at 380 or 390. So something like 450 might be the right target. In some respects, however, it doesn't matter hugely whether you choose 350, 400, or 450. to hit any of those targets is an enormous industrial effort. And the difference in the industrial effort to hit any of those targets is in fact very small. So we don't even really need to debate this question anymore. We just need to figure out what we have to do today.